Solve this system using Gaussian elimination. We're going to start by writing the augmented matrix that corresponds to this system. Now we already have a 1 here in the top left, so we want to get zeros below that. So to get a 0 there in row 2 where we have a 2, we want to take row 1 and multiply it by negative 2 and add that to row 2, and that will become our new row 2. And just be sure to apply that row operation to each column. And then to get a 0 there in the lower left in row 3 where we have a 1, we want to take row 1 and multiply it by negative 1 and add it to row 3, and that will give us our new row 3. Next we would want to get a 1 here in the middle and then a 0 below it. So to get a positive 1 here in the middle, we can simply multiply row 2 by negative 1, and that will become our new row 2. So just multiply each entry in row 2 by negative 1. Now to get a 0 below that 1, we just need to add row 2 and row 3, and that will become our new row 3. And that row operation actually resulted in getting zeros all the way across that bottom row. Whenever we have zeros in those first 3 spots, it's some type of special situation. So if I think about writing the corresponding system of equations here, going from this matrix back to the system of equations, my top row would say 1x minus 2y minus 1z equals 5, just like our original first equation. My second row says y minus 5z equals 4. Okay, but my third row says 0x plus 0y plus 0z, which is 0, equals 0. So there's no variables in that equation, but it is a true statement. 0 is equal to 0. So that would indicate then that there are infinitely many solutions. So whenever we get that type of result there where there's no variables but it is a true statement, our conclusion is that there's infinitely many solutions. But we want to be a little bit more specific, because although there are infinitely many, they do all follow the same pattern. And so we want to identify that pattern. And what we're going to do in order to come up with that pattern is I want to take one more step here with my matrix and get a 0 in this spot. So I'm going to get a 0 up there by doing 2 times row 2 plus row 1, and that will be our new row 1. Now I just want to go ahead and write the corresponding equation. So if my top row says 1x minus 11z equals 13. So using that, I want to get the x by itself. So I'm going to add 11z to both sides. So I have x equals 11z plus 13. And my second row says y minus 5z equals 4. So I want to get the y by itself. I'm going to add 5z to both sides. I get y equals 5z plus 4. So although there are infinitely many solutions, once I pick a value for z, my x-coordinate is this fixed number that goes along with it. It's 11 times my z-coordinate plus 13. And my y-coordinate is 5 times that z-coordinate plus 4. So I could pick any number I want for z. That's how I'm getting infinitely many solutions. But once I pick a specific number, there's only a certain value of x and a certain value of y that go along with that specific z. So the pattern of my solutions as an ordered triple, I want to put my x-coordinate first. My x-coordinate would be 11z plus 13. My y-coordinate would be 5z plus 4. And by doing that, we're saying our z-coordinate could be anything. So we're just going to call that z. So there are infinitely many solutions, but they all fit that pattern.